So let's do a few scenarios coming up with using our definitions of humidity. This first one, we're going to go from left to right. We're going to show this flat-bottomed flask 3 different times. It's always going to be at the same temperature for this slide. And notice that, though, from left to right, you're going to see that we are adding different amounts of water vapor. So on the previous slide, if you look up 25 degrees Celsius, you're going to find that it maxes out at 20 grams. So, oh, by the way, conveniently, the amount of dry air in here is 1 kilogram. So if you look at the table of saturation mixing ratios, we have 20 grams of water vapor can be held in 1 kilogram of dry air at this temperature. Okay, I hope that makes sense. So bottom line, if you compare 5 to 20, okay, you're under saturation. So we can come up with a relative humidity or percent relative humidity if we divide our actual amount, which is 5, divided by what the table says, which is 20. So 5 divided by 20 is 25%. Okay, so that is 25% RH. So RH, percent RH is equal to 25%. Okay, well, let's go to the next scenario, and we are going to allow evaporation to occur. Now, if we compare the two, instead of 5, we have 10, but we still have 1 kilogram of dry air, okay, and we still have the same temperature. So since it's the same temperature, then we still have a saturation amount of 20 grams of water vapor can be held at that temperature, at that mass of dry air. So again, the 10 then is what we've got. Now if we divide by what we've got, which is 10, by what we can hold, which is 20, 10 divided by 20, you're right at 50% relative humidity. All right, then the last scenario is this one. We're going to go ahead and allow more water vapor to go ahead and fill the flask. So now, and I think this is kind of neat, so because notice the water vapor, or excuse me, the liquid water has gone down. Very nice, very nice. So now instead of 10, I've got 20 grams of water vapor, again at the same temperature. So from the, remember we're getting this from the table, so the value from the table is still 20 grams of water vapor. I would max out at that mass of dry air. Now notice I've got 20, so now I've got 20 and 20 is my max. So 20 divided by 20, you're right at 100% relative humidity. Okay, very good. Okay, now this scenario, I'm going to go from left to right. I'm going to have 3 flasks again, but I'm going to go ahead and change the temperature. So the temperature is actually going to lower, keep lowering. So again, we have 1 kilogram of dry air, which is nice. Here we have the mass of the water vapor. And so this number right here is actually going to change because we got this from the table. And remember, this is for a specific temperature. We're going to be changing the temperature. So at this point in time, this is what I have. So this is my actual value. Okay, this is maximum. Okay, if we divide actual by maximum, of course that's 7 divided by 14. I'm at 50% relative humidity. So I'm going to cool that thing down 10 degrees. So now I have it, instead of 20 degrees Celsius, it's 10 degrees Celsius. So I need to get a new number from the table. So now it's 7 grams. It maxes out at the water vapor per kilogram of dry air. So notice what I have is 7, and I max out at 7. So 7 divided by 7, we are right at 100% relative humidity right there. So one of the things in when we kind of segue from kind of these thought exercises to more kind of what the atmosphere does, if you're at 100% relative humidity, you probably already know this, that actually you're probably either going to get dew, or it's going to rain, or it's going to snow. 100% relative humidity is kind of a tipping point in our atmosphere. Something's going to happen, and actually that something happened here in this scenario. So down here, this last one is now, instead of, it's cooled another 10 degrees, so instead of 10 degrees Celsius, it's 0 degrees Celsius. And so here we have, to get a new value from the table, our maximum amount of water vapor that can be held in 1 kilogram of dry air is 3.5 grams. And so, of course, what happens between these two is you have to have you have to have basically condensation occur. Okay, all that water vapor cannot be held at that temperature. So here we go. Yeah, sorry, I was drawing a blank for a minute. Now they've gone ahead and shown you how much would condense, and I bet you would buy this. Because actually, if you take 7 minus 3.5, you have 3.5. So we actually had, in other words, 3.5 grams of liquid here and 3.5 grams of gas here, which adds up to 7 grams. So bottom line is, at this new temperature, now we have a puddle of liquid, which actually it's borderline freezing, right? But it's now we have still the amount of water that did not condense is 3.5. So that's our actual. So if we divide our actuals 3.5 by what it can hold at that new colder temperature is 3.5, we're still at 100% relative humidity, but notice now we have a puddle of water.